this is an equation that we talked about just a couple days ago, yes?
Yes.
If I would say to you, how does this change from the parent function? What would you answer? How would you answer? What does this cause to change from the parent function?
Well, how it moves on the edge.
So a horizontal change, right?
Yeah.
Horizontal shift, where F's are super important.
Haha!
Yeah, I know.
This is spelled wrong. Nobody said anything.
What?
Sorry about
They
that.
said shift was spelled.
Oh, no, not shift. Shift is not spelled wrong. I spelled horizontal wrong. Sorry about that. Okay?
Is it Z-O? It's O.
What about the K? What does that change? Vertical shift. What else? What else do you know?
We have an A.
What about the A?
It's going to be a vertical stretch.
Vertical stretch or compression. There's something else about A that we need to remember.
It's negative, it reflects on the x-axis.
Right, so the sign of A matters, right? It's either going to be a positive or a negative, and a negative A would cause a reflection over the x-axis, right? Now, that's really as far as we went when we talked about quadratics this past unit, okay? But I need you to remember back to the beginning of school when we talked about all sorts of transformations from parent functions, and you need you to tell me what caused a reflection over the y-axis. Yeah, inside, right? If this term inside here, if that was negative or positive, the negative caused a reflection. Seriously, I can't spell today. I'm sorry about that. Over the y-axis. Okay? Now, there's one more thing we need to be concerned about, and we will get there eventually. I just wanted to cover these things with you real quick, because none of these things are new, are they? Okay? So, let me show you what we're doing today. I'm going to zoom out just a little bit. Or a lot, who knows. Okay? And I'm going to show you what the equation is going to look like today. Y equals plus or minus A, x minus h to the 1/2 power plus k. What's all this mean? What's the A mean?
It's a coefficient.
Oh, so vertical stretch of compression. What's the sign in front mean? If it's negative, it reflects. What's the H mean? Wait, are you telling me that everything in this equation means exactly the same thing in this equation? Yeah, you just know it's a different shape, right? This tells you it's a quadratic. This tells you it's a... That's a quadratic.
Half-quadratic.
What's something to the 1/2 power? We talked about it yesterday. What's it mean? What's it the same as?
It's the square
The
root.
square root. Okay? So then tell me what everything means in this. Whoops. Okay, same thing. Okay, what about this? Y equals plus or minus A x minus h to the 1/3 power plus k.
Oh, now it's a cube root.
So it's a cube root, so this changes everything.
Yeah.
Oh, it doesn't? It's all exactly the same thing as we learned before? Oh my gosh, this is going to be so amazing. Or at least maybe a little bit amazing. Okay? So what I'm trying to tell you is that really nothing that we're learning today is new. We have to remember back to the first couple weeks of school when we did transformations. We also have to remember a couple weeks ago when we were talking about quadratics. And we have to remember a couple days ago as we've been talking about square roots and cube roots. Fair enough? Okay. Look please on page 305 of your book. Okay, look at page 305 on your book.
My book is always so cold.
All math is cold, just get used to it. 305. I've got my 305 on the board. So everybody look up here real quick at 305. Okay? So here's what we talked about a second ago, the H. If it's inside, that's going to be a horizontal shift. Right? Graph shifts left or right. Now remember, if it's inside, it is opposite of what we think. So if it's minus 2, it's going to be right 2. If it's plus 3, it's going to be left 3. And it might be a square root. It might be a cube root. It might say instead x plus 2 raised to the 1/2, or x plus 2, or x minus 2 raised to the 1/3. But that doesn't make any difference. Okay? The square root or the cube root or the 1 raised to the 1/2 or raised to the 1/3, all that does is give it its shape. It doesn't cause any sort of shift or compression or stretch or anything like that. Okay? Vertical translation, we talked about this a second ago. It goes on the outside, that shifts it up or down exactly what you think it would. If it's plus 7, you move up 7. If it's minus 1, you move down 1. You okay with that? Reflection. There's two different kinds of reflections. We talked about this. Either the negative is on the inside of the function like this is, or it's on the outside of the function like this is. If it's on the inside of the function, that's the reflection over the y-axis. And if it's on the outside of the function, that's over the x-axis. This is all just remembering, right? Yes?
Yes, ma'am.
Okay. So look real quick at the bottom one. Vertical stretch or shrink. This is a multiplier on the outside of the function. It's a 4, you know that's going to be a stretch by a factor of 4. If it's a 1/5, that's going to be a shrink. Tell me the difference of what the difference is between a stretch or a shrink based on the number here.
Well, it has to be bigger than 1.
If the number is bigger than 1, it's a stretch. If the number is less than 1 but greater than 0, very good, then it's a shrink. Okay? So I didn't skip this one to completely skip it. I skipped it on purpose so we can come back to it now. Horizontal stretch or shrink we have not talked about since the beginning of school. So we need to remember this. This is the thing that we need to take a little bit of time on. Okay? The number can either be inside the function, like a 3, or inside the function like a 1/2. Okay? If it's a vertical stretch and it's a 4, we know that's a stretch by a factor of 4, right? But if it's on the inside and it's a 3, that's going to be a shrink or a compression by 1/3.
Because it's just reciprocal.
It is its reciprocal. Good observation. Okay? If it's inside and it's a 1/2, you think that might be a shrink because it's between 0 and 1. But remember, it's inside, so it's going to be different of what you think. It's going to be a stretch by a factor of the reciprocal, which is 2. You okay with that? Yes or no? Okay, so that's all just remembering stuff, right? Okay? So let me show you just a couple examples before I let you go. The first couple problems in your homework are matching. So it gives you an equation and a graph, and you've got to figure out which one is which. Use your horizontal and vertical shift rules. Use your stretch rules, your compression rules. Yes, you could put every single one of them in the calculator and see what it does, but if you know the rules, it's way faster. Okay? The next couple of problems says, here's an equation, like this. Here's an equation, like, I need to zoom out, sorry. F of x equals, square root of x plus 1 minus 4. First of all, it asks us to graph it. Then it asks for the domain and range. Okay? So let's go about the task of graphing it first. Do you remember what the parent function of square root looks like? Good guess. That's a very good guess. So think about this. Let's put in some values. What if it, remember what our parent function looks like, first of all? F of x equals the square root of x. Just the square, what is that? The square root of x. Okay? What if x was 0? What's y?
0.
0. Okay, so we know it's at the origin. What if x is 1? What's y?
It's like 1.
Does anybody know what the square root of 1 is?
Just 1?
Yeah, it's just 1, right? You okay with that? Scared me for a second. Okay. What's the square root of 4?
2.
Why did I choose 4 and not 3?
Because 3's not a square.
Yeah, I don't know the square root of 3, but I do know the square root of 4. So I would go over 4 and up 2. What about 9? Over 9 and up 3. So far we have something that looks like this, right? Does it go anywhere else? What about if x is negative 1? That's imaginary. Do I draw it on a real number graph like this? No, so that's the parent function, isn't it? Does that look familiar to you at all?
Yes.
Okay, good. So let's actually graph this one right here then. Okay? Let me put this up here real quick. This was our parent function in red. Okay? So how is this changing compared to its parent function?
It needs to move to the left 1.
Close. I mean, that's exactly right. Moves to the left 1. And then what does it do?
Up 4. Down 4.
Down 4. 1, 2, 3, 4. So like that? How careful was I graphing that? I was very careful with this point. How careful was I with the rest of it? No, I just went, I know what the general function looks like, right? You're allowed to do that too. We spend a lot of time being very specific about our functions. We have that already. Okay, let's worry about where the end point goes and go from there. Okay, we need to talk about domain and range because that's required on your homework. That's something that's also in our TEKS a lot that we need to make sure that we understand how to do. Yes, ma'am?
So the horizontal shift, if it's positive,
It goes left. It's opposite. If it's inside, it's different of what we think.
All right.
Okay, so let's talk about just the parent function. What's the domain of the parent function, of the red function? How far left does it go? To 0. How far right does it go? All the way. So there's two ways I can write that, remember? Like this, or x is greater than or equal to 0. Why is there a bracket here? Why is there a greater than or equal to here?
Because it ends, so don't go past that.
It ends at 0, and 0 is part of it, right?
Yeah.
I know the square root of 0 is 0. That is part of my solution set, isn't it? Okay? So what about my range? How far down does it go? To 0. How far up does it go? All the way, all right? How could I write it the other way? How about y is greater than or equal to 0? Is that okay? Good? So now let's talk about the blue function, our new function. I guess I should really call it G. That's my nickname, G. Just teasing. Just teasing. Just teasing. That's really Mr. Guerrero's nickname, just for the record. G. It's because his last name starts with a G. Just making sure. Yeah, just making sure. Okay, so what's the domain of this function? How far to the left does it go? Negative 1. Is negative 1 included? So it's a bracket. And how far to the right does it go? All the way. Okay. How else could I write that? Greater than or equal to negative 1, right? Okay. So what about the range? How far down does it go? Negative 4. How far up does it go? Infinite. Very good. Will this ever be y is less than or equal to negative 4?
Yes.
If it's a reflection, right? If there's a negative out in front, it would go like this, right? And it would be y is less than or equal to negative 4. Okay? Any questions about that? Okay? So the next couple of your questions give you your directions are to graph and then identify the domain and range, just like we just did on this one. Next couple of questions gives you an equation like this, and it says describe the transformation and then graph. Well, didn't we kind of do that on these? We just didn't write it, right? Because in order to know how to graph it, we had to know that it went left 1 and down 4, right? So just on the next couple, 21 through 25, you're going to just say horizontal shift left 1, vertical shift down 4, and then graph it. Got it? Okay. And then the last two are backwards. It gives you words and asks for an equation. It's like, give me an equation that has a horizontal shift right 1 and a vertical shift up 6. Can you do that?
Yes.
Do we need to do any examples of that, or you got that? You got that? Okay. All right. Any questions on how to do any of this stuff?
No.
Now, I'm just reminding you, none of this is new. We've done all of this before. We're just really focusing on square root functions. Now, one thing, though, before I let you go, what if this problem right here from the very beginning was not the square root of x, but what if it was the cube root of x plus 1 minus 4?
It goes down. It goes to the